Parent functions and transformations. So the parent function is the most basic function of a particular type. So linear y equal x is the parent function. Quadratic, that's a power of 2, quadratic, y equal x squared, that's the parent function. Cubic is y equal x cubed. Square root is y equal the square root of x. Absolute value is y equal the absolute value of x. Notice the straight bars for absolute value. And exponential is y equal b to the x. Now, notice there's a b there. That's because there's a lot of different exponential functions, parent functions. For example, you could have y equal 3 to the x, in which case the parent function is y equal 3 to the x. And if I said y equal 2 times 3 to the x, then the parent function is still y equal 3 to the x. But I could have another parent function of y equal 5 to the x, or y equal 7 to the x. So there's a lot of different parent functions for exponential, but we're talking about the most basic type of each function. Now the way it works then, and this is huge, so important, and students have a tough time with this, with some of it, every other function you work with is a transformation of the parent function. And there'll be other functions besides this that we work with, for example, logarithms, the log function, and trigonometric functions. There'll be others, but these are the ones we're starting with right now. Exponential, we have a whole chapter on exponential, but it's good for you to recognize it, and it's easy to recognize. Why is it easy to recognize? Because it's the only one that has the x as the exponent. Notice how with the quadratic there's a 2 that's an exponent. With cubic there's a 3. With the exponential it's always an x for the exponent. And again, every other function we work with is some kind of transformation of these functions. Now remember transformations from geometry. We had reflections, we had rotations, we had translations, and in our class we call it translation, sometimes we call it a shift. So there's going to be compressions where we squeeze things down. It's kind of like a dilation. There'll be stretches. Again, that's kind of like a dilation too. And we'll be talking about these in every single chapter. So it's really good to get them down now. Makes life much easier for yourself. Here's our first transformation we're going to look at. Notice how I have y equal x squared minus 4. There's no parentheses. And all that does, that minus 4, is decrease y by 4. Y is affected. The y values go down by 4. What I plug in for x doesn't change, but y will go down by 4. So here's a table with a quadratic. When I square negative 2, I get 4. Negative 2 times negative 2. I square negative 1, I get 1. When I square 0, I get 0. I square 1, I get 1. And 2, I get 4. And now when I plug those same values in, I'm subtracting 4. So the 4 becomes 0 after I subtract 4. The 1 becomes negative 3. And every y value here decreases by 4. This is what we call a vertical, because y is up and down. Think of the y-axis. This is a vertical translation, or sometimes we call it a vertical shift. And you'll see both of those. Often we call it a vertical shift. Here are two graphs from Desmos. Notice how in the red, y equal x squared, those are the values from the table we just graphed. And in the blue, we're adding 3 to every y, so everything went up by 3. See how 0 went up to 3? And when x was 1, it went up to 4. Everything increased by 3. At the bottom here, notice the y equal x squared minus 3. And in red, our original graph of y equal x squared. and that minus 3 decreases every y value by 3. The important thing to understand is that it's y that's being affected. That's why we call this a vertical translation. It's vertical because y is being affected. It's either increasing by 3 above or decreasing by 3 below. Remember, we call this either a translation or a shift. We just looked at a vertical shift or translation. Now we're going to take a look at a horizontal shift or translation. So we're going to the left or we're going to the right. Take a look at our original table again, right here. Same table we used before. The thing to notice is that when I change x to x plus 3, okay, been very, very important here, notice how I'm replacing x. X gets replaced with x plus 3. Whenever I replace x, and there are different kinds of transformations coming up, but if x is replaced, then that's a horizontal transformation. So the thing that's confusing, and this is where students have a hard time, is with horizontal, what happens to the points and what happens to the equation, they're inverses of each other. So weirdly, when you change x to x plus 3, you're thinking to yourself of on a graph how every x would increase by 3, but that's not what's going on here. This is an equation. It's not a graph. And what happens is actually every x decreases by 3. Observe. Okay, look at the first point here, negative 2, 4. When I square negative 2, I get 4. When I square here, I plug in negative 5, I go negative 5 plus 3. That's negative 2. Oh, there it is, negative 2. And negative 2 squared ends up being 4. When I plug in negative 4, negative 4 plus 3 is negative 1. Negative 1. And negative 1 squared is 1. And probably the easiest one to understand and keep track of is the origin, because when I square 0, I get 0. But look here. When I plug in negative 3 and square, negative 3 plus negative 3 makes 0, and 0 squared is 0. So actually, 0, 0 moves to negative 3, 0. So adding 3 inside in the equation, changing x to x plus 3, actually moves everything 3 to the left. You'll see it on the graph. And again, it's the inverse. Look at the next one. Y equal x minus 2 quantity squared. Quantity means parentheses. Minus 2, you would think, oh, on a graph, yeah, decreasing by 2 would move everything down, or actually this is x. It'd move everything to the left 2, but no, that's not what's going on here. This is the equation. What happens in the equation and what happens to the points are inverses of each other. So observe, plugging in 0, 0 minus 2 ends up being negative 2, which was the original graph, and negative 2 squared makes 4. When I plug in 1, 1 minus 2 is negative 1, and negative 1 squared is 1. So negative 1, the point negative 1, 1, in the transformation ended up being 1, 1. And negative 1 went to 1, it moved 2 to the right. Whoa. And again, the easiest one to keep track of, the easiest one to understand is the origin. What happens to 0, 0? Think of what you plug in that makes 0, 0. Plugging in 2, 2 minus 2 is 0, and 0 squared is 0. Plugging in 2 is what creates the value 0. So I can see that actually this moves it 2 to the right. So the important thing to remember is whenever you place x, you've got to know this. When you replace x, it's a horizontal transformation. And what happens to the points and what happens in the equation is the inverse. The horizontal is the inverse. And this is true of any horizontal transformation. If this confuses you, I suggest making some tables and thinking about it, but look at the graph here. This helps us understand. There's y equal x squared with the point 0, 0 for the origin. Again, let's just think about where does the origin move? What value do I put in for x that makes 0? Well, it'd be -4 right there. That's the point -4, 0. And actually, 0, 0 ended up going with this transformation of y equal x plus 4 quantity squared to -4, 0. Again, it's the inverse. Changing my equation and x, changing the x to x plus 4 doesn't move it to the right like you would think. It moves it to the left. Look at the one below. Changing x to x minus 2, x minus 2 quantity squared. So -2, it seems like it would go to the left, but no. Actually, the points end up moving to the right because the equation and the points, they're inverses of each other, what you see. So here's my original graph. 0 squared is 0. What value do you plug in for x to make 0? 2, because 2 minus 2 squared ends up being 0. So 0, 0 ends up moving to 2, 0. It actually went 2 to the right. So horizontal is definitely the more confusing of the two. We're back to vertical again. And how do I know that it's vertical? Because in every case, y is what's being affected. So here's my original parabola. That's called a parabola. It's a quadratic. And remember, every equation, this works the same way with every type of equation. Y is what's being affected. Every y will be half of what it was. Notice how 4 becomes 2, and 1 ends up being a half, and 0, hey, what's half of 0? 0. And 1 ends up being a half, and 4 ends up being 2. Because after I square it, I'm going to take half of it. So this is called, it's vertical because y is what's being affected. It's a vertical compression. And what that means is that the values of y are decreasing, they're shrinking. Look at this next one, y equals 3x squared. Every y will be 3 times larger. Y is what's being affected here, not x. So 4, go back to the original, becomes 12. And 1, back to the original, is 3 times bigger, becomes 3. 0 becomes 0, and 1 becomes 3, because I'm going to multiply it by 3 after I square it, and 4 becomes 12 again. So in this case, since every value got larger, and it was y that was being affected, we call it a vertical stretch. So if I'm multiplying by a number bigger than 1, it's going to make it larger. It's going to be a stretch. If I'm multiplying by a value less than 1, it's going to make things smaller. It's a compression. So look at the number in front. Again, if y is being affected, it's vertical. If it's bigger than 1, it's a stretch. If it's less than 1, it's a compression. So we'll take a few seconds here and look at the graphs. These are examples is all they are. They're not necessarily the same. But there's my parent function in red. Notice how when I multiply by 1/8, vertically, it gets pushed down towards the x-axis. This was a compression. And look at the bottom one, y equals x squared, so the red is the original. And when I multiply it by 10, the y values get larger. It pushes it away from the x-axis. This is a stretch. So take a look at those, study it, think about it, because it's in every chapter. You got to get it down. Here's the most confusing one, but it all goes back to when x is being replaced. There's my x squared, my x, and x gets replaced with 2x, and here with 1/2 x. These are horizontal transformations because x is being replaced. And what did we say earlier about a horizontal transformation? What happens to the points and what happens in the equation are inverses of each other. So take a look and notice that it's the x values that have to change in order to create the same y values. So here my y values are the same, but I have to make it -1 to end up with 4, the same y value, because plug in -1, 2 times -1 is -2. Ah, there it is. When I plug in -1, I get -2, and -2 squared is 4. When I plug in -1/2, 2 times -1/2 is -1, and it's in parentheses, so it's -1 squared, which is -1 times -1, which again is 1. So look at the values here. Look at the values. And notice that, remember I said it's the inverse. When you multiply by 2, your x values actually end up being divided by 2. And the book looks at this one way. What they say is that, and this is a little confusing, they say that a horizontal transformation is y equal 1/b times x squared. And they teach it such that if b is greater than 1, then it's going to be a horizontal stretch. And we'll explain that in just a minute. And if b is less than 1, then it will be a horizontal compression. Okay, well, that doesn't make sense, does it, in this context? Well, actually, when I say y equal 2x squared, I need parentheses to make it horizontal, this is really y equal 1/1/2 x squared. What are you talking about, Mr. Caldwell? Well, 1 divided by 1/2 is what I have in the parentheses there. Remember, when you divide fractions, you don't divide, you multiply by the reciprocal. Is actually 1 times 2/1, which ends up being 2. Whoa. That's what I got in those parentheses. And notice how my b, if I look at it 1/b, that value of b right there is my b. It's less than 1. And that means it's going to be a compression. And if that was totally confusing to you, listen to it again, think about it. However, remember what I said, it's the inverse. So when you see an equation, and I know it's horizontal because x is replaced, when I see I'm multiplying by 2 inside, I know what's going to happen to the points. It's going to be the inverse. I'm going to be dividing by 2 to create the same y values. And look at the last one, y equal 1/2 x squared. Well, again, if I look at it as 1/b, my b there is 2. And since b is greater than 1, that's horizontally. We're not talking vertically. It's easy to get those mixed up. Horizontally is left and right. Horizontally, that is a stretch. Well, look at the x values. Even though I see a 1/2 inside, actually, you have to double every x value. Again, 1 divided by 2, I'm dividing by 2. You have to double every x value to produce the same y value. See, plug in -4. 1/2 times -4 is -2. -2 squared is 4. See how I plug in -2 and I get the value from the original table? Plug in -2. 1/2 times -2 is -1. There it is, -1. And -1 squared is 1. 0 squared is 0, and that half doesn't affect it. Plug in 2. 1/2 times 2 is 1. Again, that's value from the original table, and 1 squared is 1. Plug in 4. 1/2 times 4 is 2. Value from the original table, and 2 squared is 4. So in this case, it's 1/b, and I'm dividing by 2, and what happens to my x values? It's horizontal because x was being replaced in the equation. It actually was the inverse. I multiplied by 2 to create the same y values. So this horizontal thing comes back to understanding when is it horizontal? When you replace x. What do I know about horizontal? What you see happening to the points and what you see happening in the equation end up being inverses of each other. Here we can see on the graph, if I look at this as y equal 1 over b times x squared, my b is actually 1/5. And because that's less than 1, think of the horizontal, they're going to call this horizontally a compression. So let's look at this. Horizontally, it's horizontal. Remember, things are being pushed in. And this is horizontal because of the way it's written. Horizontal. So you should be thinking to yourself, well, wait a sec. That kind of looks like a vertical stretch. And yes, you are correct. A lot of times, a horizontal compression, horizontally things are being pushed in, is the same thing as a vertical stretch. It's not 100% that way, but in this case, yes, it is. A lot of times, a horizontal compression is the same thing as a vertical stretch. And again, remember that if you're 1 over b, if your b is greater than 1, then we call that a stretch. If your b is less than 1, like 1/5, it's a compression. All right, take a look below here. Y equal x squared, y equal 1/5 x squared. Again, this is 1 over b, and my b is equal to 5. Since my b is greater than 1, this is actually going to be a stretch. So, horizontally, things are pushed away from the y-axis. This is a horizontal stretch. And above, it was a horizontal compression. You can pause that, look at it, think about it. Horizontally, things are being pushed away from the y-axis. So that makes it a horizontal stretch. And then you should be thinking to yourself, oh, wait a sec here. Things are being pushed towards the x-axis. So vertically, this is a compression. Yes, a lot of times, a horizontal stretch is the same thing as a vertical compression. So, if I blew your brain out and you're having a hard time absorbing all this, you go back and watch some of it again, think about it. The horizontal is the confusing one. It's in every chapter. You got to get it down. What I have here are example problems from your assignment. So you can stop here and come back to this if you need to. But I'm going to take a look at it. And there's some things here that you are going to be confused by. So some of you are definitely going to need this. Let's take a look at this example. G of x equals f of x plus 2, and g of x is my transform equation. So what is going on there? Well, remember that f of x is really y. Wait a sec here, g of x, yes, it's also a y, a different y, but it's a y value. And what is happening is every y in the g of x transform equation is being increased by 2. So the y's are being increased by 2. So what that means is that if I go to my original graph, everything is just going to go up 2. And that's all you do. So -4 will go up to -2. And -3 right there will go up to -3 up 2. And 3, it will go up 2 also. Now it's down at -1, so it'll go up 2 to 1. And I have a hard time with straight lines, but we'll give it a shot. And you can draw this in WAMAP and you're in business. Now for this next example, this is f of x. And x is being replaced with x plus 3. When x is being replaced, I know it's horizontal. And I know that what happens to the points, that's the graph, and what happens in the equation are inverses of each other. So plus 3, wait a sec, that seems like I'd go to the right 3, but no, what happens to the equation, the points are inverses. So this will move everything 3 to the left. And so I'm going to take every point. Here I am at -4, and I'm going to move it 3 to the left. 1, 2, 3. And the ordered pair -3, 3 will move right there to 1, 2, 3 to the left. And the point 3, -1 right there will end up moving 3 to the left. 1, 2, 3. And again, I just take and draw my straight lines in, and off you go. So in this one, f of x is being replaced. X is becoming x minus 2. Again, I know x is being replaced. That makes it horizontal. Horizontal. And I know horizontal is the inverse. What happens in the equation, what happens to the points is the inverse. So -2 seems like it'd move it to the left 2, but actually this will make everything go 2 to the right. So -4, 0 will become -2, 0. -3, 3 will become -1, 3. And 3, -1 will become 5, -1. Move everything 2 to the right. So when you look at these, you need to ask yourself, which variable is being affected? Can I spell being? So let's go to the right up top first. So f of x is really y, and I have a y here. So this y is going to increase by 93. So since y is affected, I know it's vertical. And what will happen to y plus 93? Every y will increase by 93. So y is up and down. So everything's going to go up 93 units. In the bottom left, x is going to become x minus 86. So since x is being affected, it's horizontal. And I know that horizontal is the inverse. So minus 86 seems like it'd go to the left, but actually it's going to go 86 to the right. It'll go right to the right 86 units. Last one in the lower right corner, x is becoming x plus 39. So just like the last example, x is what's changing, so it's horizontal. And I know horizontal is the inverse. And so that means in my function, it's going to go the other direction. So plus 39, not going to the right, actually, it's going to go to the left. So go to the left 39 units, horizontal, left and right. In these two examples, f of x is really y, so I'm taking 1 over 81 times my y. So y is going to be affected. That means this is vertical. And what will happen then? Well, y will become, I'm going to be dividing it by, it's not the inverse, only horizontal is the inverse. Every y value will become 181st of what it was. So basically every y value will be divided by 81. So it's going to be compressing it by a factor of 81, meaning it's going to be dividing by 81. It's going to get smaller because you're dividing it by 81. Only horizontal is the inverse. Look here, x is being changed to 1 over 73 times x. So x is being replaced. That means this one is horizontal. And horizontal, we know, is the inverse. Not vertical, just horizontal. So dividing by 73 actually is going to end up multiplying every x by 73. So it's going to end up being stretched. And what we say, remember the book treats this like, hey, it's 1 over b times x when I replace x. And if b is less than 1, they call it a compression. Horizontal we're talking about. Don't confuse that with vertical. And if b is greater than 1, it's a stretch. Well, again, it goes back to the inverse idea. I'm dividing by 73. What happens to the points is they're going to be multiplied by 73. That's what makes it a stretch. So once you get the idea, you can just fly through these. Here's what I'm talking about. Y is going to be affected, and it's going to increase by 66. Y is up and down. This will go up by 66 units. And the next one, x is being replaced. Since x is replaced, it's horizontal. Horizontal is the inverse. Minus 40, instead of going to the left, it actually goes to the right. And it will go 40 units to the right. The next one, y is being affected. And y will be decreased by 44. This will make it go down by 44 units. For the next one, x is being affected. So this is horizontal. Horizontal is the inverse. It's x. It's horizontal. It's left and right. So it's plus 12 instead of going to the right. It ends up going to the left, and will go 12 units to the left. Down below, same idea. See how x plus f, well, let's do it this way. Y equal x squared became y equal this. Well, x became x plus 50. That means this is horizontal, and horizontal is the inverse. And now it's horizontal, that's left and right. So plus 50, it's not going to go to the right like you'd think, it'd go to the left. So this will be a shift to the left. Oh, it already says it, shift. Well, that's all I needed. Number 2, x squared plus 50. So y, this is y. Y is being affected. Y will increase by 50. This will move it up. And then again, it's a shift or a translation. And it'll go up 50. For number 3, it's a square root function. And y equal the square root of x is my parent function. Every y will increase by 50 because I'm multiplying by 50. So this will be a stretch by a factor of 50. Down below, I'm multiplying by 0.8. 0.8 is less than 1. This is again vertical because it's y that's being affected. Vertical is not the inverse. If I multiply by 0.8, it decreases something. So this will be a compression. It's going to shrink the graph by a factor of 0.8. Last few examples really fast. So let's start in the top right. We can see that g of x is y, so all these are really just y's. And try again. And y is my old equation. I'm taking my old equation, increasing y by 5. So I look at my table here. Negative 5 is going to become 30. So, and negative 4 is going to become 21. And looks like that is the one I'm looking for. Every y value, if you look at the table, remember that's x and that's y, it's sideways, will increase by 5. Lower left, this is horizontal because x is being replaced. And I know that horizontal is the inverse. So what happens to the points is x is being changed, and x, rather than increasing by 3, it's the inverse, will decrease by 3. So some of these points won't be below. For example, I'm going to decrease x by 3. This one becomes -8. This one becomes decreased by 3, -7. And notice those aren't in the tables below. This one becomes -6. That one becomes -5. That one should be in the table. Decreased by 3. This becomes -4. And 0 becomes -3. Now these here are in the table. I should looking for a table with an x of -5, 4, -4, 1, and -3, 0. -5, 4, -4, 1, and -3, 0. Looks like this is the one right here. And the last one, f of x is y, g of x is y. I'm taking my old equation. I'm going to multiply every y value by 3. So when I look at my original table, I'm going to multiply by 3. So 25 becomes 75. I'm looking below for a 75, and I only see 1. So y was being affected, and y got multiplied by 3.